This conference will now be recorded.
So Percy, we can wait for 5 minutes and then start.
Yeah. Okay. Is it visible, my screen?
Sure. Thank you. Thank you.
It is visible, yeah.
Okay, I'm facing some problem, I guess. This is okay. This is the common chat window, right? No. Okay. So I'm facing challenges to minimize this shout. Can you assist? This one, right side panel.
There is a sign which looks like two arrows. See?
2 arrows. Okay. Thank you. Yeah, got it. And then this and this. Yeah.
Downloaded the app.
Yeah, I tried to download the app. I'm facing some problem. I think there is some OS issue or something like that in the computer itself. It's not
Okay, but now
supporting this.
you're doing it from the app only, no?
Is this the app?
Yes, I think so. Otherwise, your
Okay.
browser
Okay.
begins here.
In the previous class, I tried from app, but I joined through web. Now it's automatically. Now I'm restarting this particular computer after quite a lot of time, 1 or 2 weeks. Then it's automatically getting installed. I don't know. It's now
Okay.
allowing me to join. Then
Okay.
that's cool.
Yeah, they are mad actually.
Hmm.
Oh, I should not put that in record.
You already.
Okay, what I will do is I am making you Satyasi as one of the organizer, and
Yeah.
probably I will make Nivedita organizer, and then I will leave.
Okay. Make Nivedita organizer then.
Yeah, so both you and Nivedita are organizer,
Okay.
and I will leave.
Okay then.
Okay.
Fine.
Oh,
Okay. Hi folks. I'll be starting within 2 minutes. And thanks for joining in this this so odd time, right for you. Hi Funny, how are you? Am I audible to everyone? Girish, Madhusmita, Tarundeep, could you please answer?
Yes, sir.
Yes.
Okay, perfect. That's great. 1 minute to go. So is this the first class of time series? I guess so. Okay. Okay, let's start then. So for some of you, it will be a recap class for time series basics, and most of you are new. It's the first class from my side in time series. Okay, so let's start. So the agenda will be a little bit something like this. Understand time series data, autocorrelation. I'll be explaining what are the components of time series, and that's it. And some of the basic forecasting and all we will be discussing today and tomorrow. After that, in next week, I'll try to move little bit advanced items. Okay, so that's the target. So first of all, let me show you. This is a board. Yeah. So, can you please give me some example? So, what is time series? What is your idea about time series? Let me check first. What is time series? You may answer. 1 or 2 lines, 2-4 volunteers. What is time series? Non-frequency type data. Okay, Sonali. How are you, Sonali? Yeah. Okay, great. So non-frequency type data, yes, it's a non-frequency data, correct? It's a type. Graph data. Thank you. Have a graph data. Next, any other example? Madhusmita, graph data, right? Graph. Oh, everything can be plotted in graph, right?
Yes, sir.
Okay. Any other
Sir,
example?
anything we will not plot, but when it is related, like the values, then only we can plot it in this
Okay,
graph.
related.
It can be plotted.
Okay. So any number can be plotted. In
Yes, sir.
that sense. Okay, graph data. Okay, graph data. Then the data which varies with time shows specific characteristics as it moves with time. Data which vary with time. Okay, so I'll take this answer. Data which vary with time. That is time series data. It's a very simple definition. Bipin is providing, Preeti is providing. Yeah. Okay. Okay, then let me tell you first. So there are 2 types of data. So I will start with types of data then. So there are 2 types of data: non-frequency data and frequency type data. So non-frequency data means yield of paddy, literacy rate, population for different periods of time of a particular region. So non-frequency data. So after that, frequency data means number of students score below 30, between 30 to 50, between 50 to 70, and between 70 to 100. What is the fundamental difference? Fundamental difference is frequency type data where no individual in, so two types, right? Frequency and non-frequency. In frequency, the primary thing is individuals are not getting in importance. Individuals not getting importance. Right? This is frequency type data. And here individuals are getting importance. How? Let me show you. Like paddy production in Gujarat for a particular year, it's 800 quintal. West Bengal in that particular year, it's 700 quintal. And in Karnataka that might be 650 quintal for a particular year. So you see Gujarat, West Bengal, Karnataka, they are individuals who are getting importance. So this particular figure owned by this particular individual, which is Gujarat. Okay. Now, other example, let me give you other example as well. So 1997 in Gujarat paddy production, 1998, 1999, 2000. Okay, yearly paddy production. Suppose this is 500, this is 550, this is 553 in quintal, this is 600. So again, these years are individuals, right? These time points are individuals. So again, it's a non-frequency data because individuals. So this 500 is owned by this 1997. This 550 is owned by this 1990. So that's why these are non-frequency data. Okay, the first one is a particular type of non-frequency data. We say this, we termed this as spatial data. And this one we termed as time series data. This one we say time series data. Okay, time series data. Okay, this is time series data. And let me go back for your to clarify the concept. Let me go back to the frequency data. Frequency type data means, so can you can take anything like in a class, in a particular class, what is the distribution. So you studied statistical distribution, right? In statistical distribution, those are random variables, right? Random variable have a frequency distribution, you can collate. So always at first axis, one axis is number and another axis, this axis is a number or value, and another axis is frequency. This is your frequency type data. So let me give you an example. In a particular class, what is the distribution of numbers in mathematics? What is the distribution of numbers? Suppose in 10 to 30, number of students are number of students scored between 10 to 30 is 5. Number of students scored in this range 30 to 60, there are 15. Number of students scored 60 to 90, again 5. Now 90 plus, there are 2. So you see, numbers are getting important. The ranges, the value ranges, the number of you can say whatever variable you are treating, the range of that particular value, is getting important. So it's not an individual, it's a variable. So that's why these are called frequency data. That's the fundamental difference between in non-frequency data and frequency data. Non-frequency data always belongs to some individual, and frequency data always belongs to a variable, range of variables. Okay, that's the fundamental difference. So I'm moving ahead then. Hopefully there should not be any question. Quickly, video time frames data. So okay, funny vision, the video time frames data, funny. Okay. Yes, video time frames data is a time series data again. The fundamental is it's varying against time. That's it. Anything varying against time is a time series data. Labeled against time. That's it. Okay. So I am moving ahead. Hopefully there should not be any question. Now new. Changing the board. Sorry. Now So next, so these are, you can see Uttar Pradesh, Maharashtra, Bihar, West Bengal, some population. These are non-frequency data, spatial data, you can say, and these are yield of paddy and all. These are frequency data. Okay, so let us understand little bit time series data. Okay, let us understand the time series data. So first of all, in any time series data, so let me open an Excel. Open Excel. Then time is 20180101 0201 020. It's a daily data. Now I am just doing a simulation. Date, value, sales in 1000. So it's a shopping mall data, shopping mall sales in 1000, and I have just randomly simulated this data. Okay, so these are the date, not thousands, so make it sales, normal sales in the INR. Okay, for a particular shop. So first question, is this a time series data, sales and date? Quickly answer me. Is this a time series data? Okay, perfect, because it's varying with time. Okay, and another property, so another property is there. See, another property, the times are, so what is this? Is the first date, this is the second date, this is the third date, this is the fourth date, this is the fifth date, right? This is the sixth date, right? So what is the period we can observe in this data? It's, what is the period? Any answer? Any answer? It is daily, monthly, yearly, quarterly, bi-monthly, what? Okay, perfect. Daily is the answer. Perfect. So how many typical time series period we can observe during analysis? Daily, monthly, weekly, yearly, right? Okay, so this is the period of time series or frequency of time series, whatever you can say. So it's just you understand, that's it. Don't need the terminology for this. Another thing, so what is the difference between these periods? What is the difference? So 1 after 2 what is the difference? Difference is 1 day. And what is the difference between these two? Again 1 day. What is the difference between these two? Again 1 day. Right? 1 day. So this kind of time series data where the difference in the time or difference of the data points, that time data points is same, those are called equispaced data. Equispaced data. The gaps are equal, that means the gaps are equal. Okay, if the gaps are not equal, then what we need to do? That's the question. It's a big question, right? So let me delete some data. I'm deleting this one. I'm deleting this one. I'm deleting this one. This. I'm deleting. Okay. Now let me calculate the gap. This minus this. So these are the techniques. Just you can take note. These are the techniques you need to understand before going to advanced time series analysis anytime in your career. So that's why I am just saying you. Just understand the relevance. Okay. So gap. So these are the gaps basically. These are the gaps. So 2 1 1 1 1 1 1 1 1 1 1 1 1, then 2 1 1 1, then 5 1 1 1 1 1. Okay. So what should be the gap of this time series? How you can understand? What should be the gap? Actual gap. What should be the actual gap? What is the gap length? Should be 1. Why, Sonali? Can you answer typing? Why? It should be 1. The 1 is correct answer. And why? I need the why. There's the major gap. Okay, perfect. Any other one? Any other volunteer? We have so many bright minds. Answer. Preeti, Manjari, anyone? Girish, Devojyoti, Yuvraj, anyone? Bipin. Okay, 5 maximum period. Okay, Pranavendra, 5 maximum period. It's our objective daily data. Then should be 1. Okay, if our objective is daily data, then should be 1. May not be 1, but Equispaced we can perform easier analysis. Okay, perfect. Most repeated value. Don't get confused. I will say rather all your answers are correct. Depends on the analysis. Depends on the analysis, right? So basically, if we consider 2 days gap, then 2 days gap is almost available in this data. We need to remove all alternative days. That's it. If we are going to consider 5 days gap, then also it's available. But if we are considering 5 days gap, then the data point, the information will get decreased significantly. We might have availability, but the things will be decreased significantly. So it's better that in this case, in my opinion, we should go for 1, because let me count that how many are 1, how many ones are there. I'm just using some basic Excel formula. Don't so let me count this one. Count if, right? Count if. Let me count if range. This is the range and this is the criteria. Okay, so 89 1 2 2 and 5 1. So 89, so its majority is 1. If there was 50 40 this kind of ratio, then we should go for 2. 50 50 40. So if the count was 50, then here we have 45, then here 4, then we should go for 50. But 89 is a clear majority, so we can go for 1 gap. So another thing, then we are deciding the gap should be 1. You can also perform with 2, but if you use 1, you may use more information. for your analysis. Okay, so now, so these are missing values, right? In between, these are missing values, right? So first of all, to find that out, we need to find that missing values. So how we can get this missing value? Because anyways we need equispaced one, right? For time series analysis, in our scope, time series analysis, we need equispaced data. We need equispaced data. So we need to make this data equispaced as well. How we can do that? That's the question. So any idea, any suggestion? So there are 5 missings as well. There are 5 missing. There are 2 missings. So any idea how we can do that? Missing value imputation. Extrapolate it, okay, Girish? My mean value of them, yes. Not extrapolate, it's interpolate, right? It's in between missing you are getting. Extrapolating, you are going outside the range, Girish. Okay. Immediate next value or mean value of the previous and next time. Okay, perfect, Nivedita. Girish, okay, Girish, and that's it. So what are the way to impute? We can impute in the following process, using this following process. Yeah, we can impute using these following processes. Imputation, impute missing values. Impute missing values. First way is last 2 data point average. Last 2 data point average. Not necessarily this 2. 2 is not right always. You may use 3 as well. Last 2, 3, 4, 5. Depends on you, how you are looking at that. Okay, last 2, 3, 4, 5 data points average, and average in average. So average you can use mean, median, median, mean or median. Okay, and another thing you can use, that is called trimmed mean. Trimmed mean, I will explain that to you. I am writing this here. This is trimmed mean. Trimmed mean. Trimmed mean. Mean, median, or trimmed mean you can use. Okay. Trimmed mean means you are removing the outliers and you can taking the mean of the rest. If you are deciding you are going to impute that with last 10 data points and you want to remove the outliers as well, you can remove the outliers. Suppose the first 2 and last 2 data point are outlier according to your judgment, then 6 values we are remaining with. For 6 values, for those 6 values you are taking the average and you are imputing the next value by that. Okay, that is one way of imputation to make that equispaced. After that, the point number 2, how you can do that. Point number 2 is last 2, 3, 5 data points.
Can you trim mean once again?
Which one?
Trimmed mean.
Yeah, trim mean. Let me explain. Yeah, I will explain. Let me explain after point number 2. Okay. Yeah, point number 2. Now point number 2 is you are taking average of previous and the next value. Taking average, taking not average, taking mean of previous and next value. Okay, this is another approach. So I'll stop with this two, and I will explain. So you were noticing that I put here average, under average we are putting mean and median. These are only terminologies. Don't worry about that. Let me explain that to you. Okay, let me explain that to you. So let me explain this to you. So average, though you already went through these classes, so let me explain this to you. Average, first one is mean. So mean is arithmetic mean 1 plus 2 plus 3 by 3. This is called arithmetic mean, right? And this is geometric mean. Geometric mean means 1 into 2 into 3 to the power 1/3. This is geometric mean. And harmonic mean. Harmonic mean is 3 by 1 by 1 plus 2 by 1 by 2 plus 1 by 3. This is your harmonic mean. Okay, so if any observation is 0, then geometric mean will vanish. That's why usually we don't use geometric mean, right? So I am discarding here. We are not using geometric mean. Harmonic mean, it's a special case. So you must have done that speed and distance problem. There we can understand it's a special case, very special case. That's why we don't usually use harmonic mean. In some special cases we do apply this harmonic mean. And this arithmetic mean is very frequently used. 1 plus just adding all the observation divided by number of observations. Okay, so this arithmetic mean is referred to as common mean for us, right? Common mean for us. Now for arithmetic mean there is a drawback. Like it is considering all the observation. Like I am taking average of this all the values 1 2 3 4 5 and 100. Let me know what is the average of these 5 numbers. 100 I have mistyped 100, and now what is the average of this 100? These 5 numbers 1 2 3 4 5 6 numbers. Let me know quickly. 1 2 3 4 5 and 100. $31.66. Okay, so six numbers, right? Now is this an outlier? This is an outlier, right? I mistyped this. This is an outlier. So this outlier is severely hampering this our analysis. Our actual average is moving out of range, right? So trim bin is a process of removing the extreme outliers and calculating the average of the rest. Okay, so now 1 2 3 4 5 and 100. So 5 and 100. So I am defining a trim mean. I will trim the top one value and at the bottom one value. I'm just trimming that. That's my protocol of trimming. Just trimming that. I am trimming this out and I am trimming this out. Okay, trimming this out. I am taking the average of the rest. Average of the rest is 3.4. Sorry, not 3.4. Average of the this is 3.5, I guess. 3.5. Yes, 3.5 is the average. So now see, this is quite close and quite familiar and quite a good representative of the data set, most of the part of the data set. This is called trimmed mean. So instead of average, instead of simple mean, the arithmetic mean, we sometimes use trimmed mean whenever there are lots of presence, there is a lot of presence of outliers within the data. That is called trimmed mean. The terminology is trimmed mean. Okay, now, so what are other averages? Let me complete that. So mean is one average, and you know, as you know, median is another average. Median, another kind of average, or measure of central tendency. Median is the middlemost value. Median is another median, and third one is mode. Mode is the most frequent value, and median is the middlemost value.
Sir,
Middle
how
value.
do we, sir, Shunali here. So how
Yeah.
do we understand which are the outlier value?
Outlier. Oh, there are. Okay, let me explain. Most frequent value. There are lots of things you can understand. There are lots of detector of outlier detectors you also have. Okay, I'll explain that. Let me try that quickly. Try quickly explaining that. Start. So outlier, for outlier in a data set, you can use one formula. There are lots of formulas, Sonali. You can you can refer to the previous class note. There are lots of things. So let me still explain another one. Like you know, interquartiles Q1, Q2, Q3, Q4, Q3, Q4. There are 4 quartiles. So Q3 minus Q2 is called interquartile range, right? So anyone which is below Q1 minus 1.5, Q3 minus Q2, interquartile range. Below this, anyone is below this, any observation is below this is outlier, and Q3 plus 1.5 into Q3 minus Q2. Above this value is outlier. So this is called inner fence. This is called outer fence. Inner fence, IF, and this is called outer fence in a data set. So anything below inner fence and anything above outer fence is outlier, can be considered as outlier. This is one way of detecting outlier. There are many more ways. I'm just saying stating one way. This is very frequently used in for a single variable in univariate analysis. Okay, is that fine? Yeah, box plot may help. Siddharth, you are right. How do you know what is outliers? 19. Okay, 19.16 is correct. 19.16. Okay, no problem. That's fine. 19.16 is also very high. So this is the in this way, to make a time series data equispaced. The summary is, the make a time series data equispaced, you have to apply some imputation techniques. Okay, some imputation techniques. So those imputation techniques I have briefed you just. Okay, you can take a note. So then I'll be moving on then here. So understand time series data. So you can see this is time 1, 2, 3, 4, 5, 6. These are the index of time basically. Dates are not here really, but these are index of time, whatever you can see in the board. Okay, in the screen. This is original time series 1, 2, 3. So this is some yield of paddy or something like that. This data is original YT. Time series is represented by YT, Y suffix T. Okay, and this is lagged 1 time series, and this is lagged 2 time series. Okay, so again lagged 1 and lagged 2 time series. What is this and why this is important? Let me explain to you. So suppose you have a time series like this is your first time point t1, this is t2, this is t3, this is t4. Okay, and this is 1 1 1, the value 1 2 1, 2 1 1 and 2 3 1. Okay, these are the values against those times. Now this is a time series data, and this time series data and another way I am stating one regression problem. Suppose your car speed and distance. So car speed and distance. So distance is your y and car speed is your x. Okay, now I'm just setting the 30 40 410 32 452 33 475, something like that. This is car speed and distance. This is your x and this is your y. So this is a typical regression problem. You can see this is a typical regression problem, right? In this regression problem, what is the speciality? The speciality is the rows are independent. This row and this row, they are independent. So this is a different card. The cards, the data has been collected from different cards. Then you can do this regression. The rows are independent in nature for regression problems. And but in time series problem, rows are not independent. Rows are really not independent. So I'll okay. So these rows are not independent. This 121 can be dependent on 111. This 211 can be dependent on this 121. This is 231 can be dependent on 211. The rows are not really independent in time series. Okay, so you can say stock price. So if anybody is investing in share or studying share regularly, culturing these things, they will definitely know that so share market tomorrow's share market will be dependent on today's condition in the usual cases, right? Or might be independent, might be dependent. And today's stock price, today's share price for a particular share might be dependent on previous week data or yesterday's price or something like that, right? Those are independent, so varying in time and dependent on previous information. Usually there is a dependency, there might be a dependency or might not be a dependency. So in time series data, these rows are not independent. That is the fundamental difference between time series and regression. In regression, rows are independent, and in time series analysis, rows are not independent. This is the fundamental difference. You should understand that and you should realize that as well. Okay, so any question on this? Let me know. In time series, rows are independent. Sorry, dependent. In regression, rows are independent. Hopefully there is no question. Yes, yes, Girish. Otherwise, it's hampering the assumption, basic assumption. Whoever is doing, so it's in time series problem, we cannot apply regression. Whoever is doing that is wrong. Or maybe for any college assignment, they are doing something with the assumption that rows are independent. That's why they are applying time series technique. In regression technique in time series data. In regression technique means linear regression, non-linear regression cannot be applied in time series data. Please repeat the conclusion once. Yes.
This is one thing more. When we are doing any data imputation, can we use linear regression?
Yes, we can do case by case. Depends. Depends. Yes, we can do.
Okay.
Depends. So don't worry, it's not that much heavy thing. So you will come to know anything which is varying with time series. Before applying regression, you must be sure that it's not time dependent actually. It's not time dependent actually. Okay, if time dependent, the rows are not independent. So yeah, yes, Pony, I'll repeat. So the thing is that in regression technique, these are the rows, right? These are the rows. Rows are independent. So take any regression example under the hood, any regression example. So that might be your phone line order number of order prediction. So different order line, so number of the time prediction in so any kind of regression problem you are doing, you are performing, the rows should be independent. The rows should be independent. But in time series, rows are not independent, might not be independent. Rows might have some relationship. Like 121 might be dependent on 111, 211 might be dependent on 121, 231 might be dependent on 211. Like in stock price. Stock price, you can say that stock price, like in stock price, so this might be the curve. This is a time series data, right? It's deep, it's varying with time. So this point can influence this portion as well during forecasting. So there might be a dependency, and this might influence this particular data point as well, right? So it's time dependency. There is a time dependency. The rows are not independent. So the times are itself, they are this time is history for this time. T3, T1 is history for T2, T2 is history for T3. So the rows might have some dependency. So that's why it's time series. So hopefully I'm putting much effort to clarify this. Hopefully it's clear to all of you. The basic assumption. Okay. Okay, now, so they are dependent. Rows are dependent now. That's why we need to measure the relationship between them, right? We need to measure the relationship between them. That's why we use lag. That's why we use lag. You see, 130 and 123 are aligned now. Lag 1. 125 is aligned with this previous one. That is 130. 130 is aligned with 125. 125. So the time series has been shifted by 1. Shifted by 1. Okay, 1 plus in the future it has been shifted to 1. That's why it's called lagged one step. Okay, now lagged one step, shifted to 1. So lagged one step. Now time series shifted to lag 2. So you see 123 has been lagged to step 2. So at time point 3 I am seeing one data, the data for first point. At time point 4 I am seeing data for second point. At 5th I am seeing data point for third step, actual data for third step. or third time step. So that's why it's lag 2. Okay, and to find out the relationship between these two lags, so time series, to find out the relationship between two lags means original time series and lag the previous day time series, or previous to previous day time series, previous to previous value. So we use this lag concept and we can calculate correlation between this. Correlation is a measure of linear association, right? In time series we apply in this manner correlation. First we lag the time series and then apply correlation to measure the relationship between the history, the previous day or day, the day before yesterday, or the day before yesterday, the day before that. So in this manner. Okay, now so you can see the scattered plot between yt minus 1 and yt minus 1 means 1 step lag and yt means 1 step lag. Yt means original time series. Okay, let me clarify that here. Yt is original time series. Original time series. Yt minus 1 previous day data. So that means lag 1. Lag 1. Yt minus 1, yt minus 2. All t minus 1, t minus 2, these are in suffix. Lag 2. Okay. Yt minus yt plus 1. So I am shifting the time series. I'm shifting the time series in front. Yt minus 1. Yt minus 1. I'm shifting the time series little older, and yt minus 1 I'm shifting the time series little advanced, little younger, right? So this is called lead. The same thing, lead 1. Yt plus 2, yt plus 2, this is called lead 2. Okay, these are simple terminologies, don't get confused. Now, so lag, now to measure with the lag, with the previous day or the next day or the previous to previous day, we use correlation between the lags. This is called correlation because the correlation is with itself only. There is no new data we are bringing in the picture, right? It's the own relation with its own. That's why we call this autocorrelation. You see, and this is the formula. This is very similar to the correlation formula. Very similar. So it's not similar. It's exactly same. The actual mean is getting used every time instead of lagged mean. Actual mean is getting used. Else everything is fine. You see, let me know any question. So you already have this presentation. Just study till this time and take 2-3 minutes and let me know if you have any question.
What is K here?
Yeah, K is lag.
And T is also lag, you said, no?
No, T is the T is not the lag. T is the time series representation. T means time. And
Okay, so
minus
K
1 here minus
that.
1 is lag. 1 is lag. Sorry, 2 is
One
lag
is
here.
Here K equal to 1.
K equal to 1. Perfect.
Okay.
Here K equal to minus 1. For lead K, don't get confused yourself. We are not using lead. Just understand lag. That's it. You will come to know. You will understand lead It's the same thing, lead and lag, same thing. Okay, so just lag, understand the lag, that's it. Okay.
How is this autocorrelation coefficient coming up?
Yeah, autocorrelation means a simple correlation between two lags, y and y minus
Okay.
t. That's
Okay,
it.
okay, thank you.
Correlation. You know correlation, right?
Yes, yes, yes.
Okay, perfect. So here it's correlation between the two different representation of the same time series. Correlation with itself. That's why auto. The name is auto. So these two, YT, original and lagged, these two, original and lagged one, we are calculating correlation between these two, original and lagged. Okay, naturally the first one will get removed. The first one we will not consider. We need to align, right? We need to make. So we'll start from row number 2 for lag 1, and these two columns will calculate the correlation between these two columns. Starting, first one is starting from 130 and second one is naturally starting from 123. And then if we are going to calculate correlation between, if we are going to calculate the correlation between if you are going to calculate the correlation between yt and yt minus 2, that is lag 2 correlation, then we need to start from 125, that is row number 3. We need to align, right? Row number 3, 125 to 160 for the first column yt, and this is as it is. This will get used as it is, 123 to 157. It's called autocorrelation.
Sir, why can't we use lead here in this formula?
Which one? Why there is yt? There are two y. What is mean of which one? Correct. Bipin, yeah, I'm coming to you. Is this yeah, Bipin, let me answer Bipin first. Yt and yt minus k, right? Yes, yes. Bipin, it's only y bar of yt. Y bar of yt every time we are using the entire data. That's the only change in the formula. Y bar of the original time series, that is starting from 123 to 160, we are adding and dividing by 12 number of observation. That's it. Okay, okay, yeah, now go ahead. What's your question?
Sir, actually, I was
Yeah,
curious to know why are we using lead in this autocorrelation formula?
okay, why are we are not using lead, right? That's what you were saying.
Yes.
Okay, I'll answer that. Yeah. So see, for yt minus k, yt is lead. Can you understand? So we are already using the lead for yt minus k. If yt minus k is our original time series, then yt is lead for that. Are you getting my point?
Yes, sir, we are taking that, but here the original time series data is
Yeah.
considered to be the lead, and then the next lag is considered to be the lead for the next lag. Okay,
Yes,
but
yes.
in this case, can we start with this lead itself, like t plus 1
Yeah,
or t plus 2?
you can rewrite the formula simply. You can rewrite the formula, and in place of k, it replace t by t minus k. You will get that. Replace t minus k by t. That's it. Replace t minus k by t. You will get the lead formula as well. Same thing. Replace t minus k by t. Just replace t minus k. Then this will be t, this will be t, right? Then t minus k will be replaced by t. Then this will be t plus k.
Yes, yes.
This will be t plus k. In the below it will be again t plus k. And here t minus k, range of t minus k will be starting from 1, right? T will be replacing by t minus k, the t minus, then t will be replaced by t plus k plus 1 equal to k. Then the range will automatically get changed. Understood? The simple
Yes,
transformation, that's it.
yes, sir.
Origin
So the
shift.
range will be not started from t is equal to k plus 1, rather it will start from t minus k is equal to k plus 1. If I'm right.
Yes, 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 yes. It will start from 1 to n plus k. Okay.
No, what will be the range for the numerator? T is equal to k plus
Yeah.
1. What will be
No,
the
no, no.
one?
Yeah, then t will be starting from 1 to n plus k. That's it. Because you are replacing t minus k by t.
Yes, yes, sir.
Then t minus k range, this one will be simply 1 starting from 1, and this will be starting from n plus k. This will be
M
going
plus.
to n plus k. That's it. Same thing, the origin shift, nothing else.
And sir, the denominator, how it will change?
There again t plus k. This will be t plus k. T will be replaced by t minus, so this will be t plus k again. So same thing like that.
And sir, the range.
Yeah, range will be t minus k, t minus k. So the range will be k plus 1 to n plus k.
Okay, sir.
Okay, just try replacing yourself and let me know if you find any
Okay,
difficulty.
sir, I'll do that. But so it is possible now, right? Future
Yeah,
prediction
it's
value.
possible. Definitely. It's the same thing, same thing, same thing.
Okay, so what are the cases we actually take a future value, like predicted value, and we
Yeah,
actually do
yeah,
these things? What are the
yeah.
like cases? Because normally we are taking the existing values, but here t plus 1 is actually a future value, predicted value. So in that
Yes.
case, what are the scenarios, sir, in industry we actually use that kind of a case?
Okay,
Just a
let me take that question at the end of the class. Okay, Sonali.
okay, sir, no issues.
Okay. Okay. Sure. Yeah, that's it. Let me move forward. Now just open R little bit. Let us do some tasks in R. Just open R. When you have received my files, right, everyone, so you can work with me using those codes. Time series in R. Now just one basic. So first set your directory properly, otherwise you will not you might face trouble. Just open this R basics.R, the first code. Okay, first you set the directory properly in the code at the top. Wherever you are putting the entire data set shared by me, just put that, just give that properly. Now TS data, just read that data. So in TS data, you can see this data set. After that, this employed woman, the actual data we are storing in a variable called my vector. Okay, my vector, and just see the data. Is this a daily data or monthly data? What? Let me know. Say daily data, monthly data, yearly data, quarterly data, decennial data, sentimental data. Let me know. Centenary data, sorry, not sentimental. So careful question, carefully answer this question, okay? Monthly or daily? Daily, Nivedita is saying daily, Preeti is saying monthly, Manjari Lahoria is saying daily, Bipin monthly, Grish Ranjan monthly. Whoever is saying daily, please look into the data another time. Manjari, Nivedita, look into the data another time. Okay, yearly. Why yearly? Funny? No, no, no. Why annual? Sonali is yearly. Again, Sonali is saying yearly. Am I wrong? What is the period of repetition? Please check. Whoever is saying daily and yearly, please check another time. Try to so you need to find out the gap between two data points. You need to find out the gap between two data points. That's it. Okay, it's monthly funny, right? It's monthly data because it's there is a date. I understand it's a date, but so first date of every month. First date of every month. Okay, first date of every month. Now what is the first date or first month? Let me know what is the first month and what is the last month. What is the first month and last month with year? I need with year the answer. Okay, lots of answers. Yeah, first month of 1964. And let me scroll down this. Okay, instead of scrolling, we can, so it's a ordered data, we can easily see. Instead of scrolling, let us try one smarter way. So this is TS data. TS data 1/1. Let us print this. So 1/1/64, first month of 1964, and TS data n row comma 1. N row of this TS data. N row means number of rows of TS. So I am finding out the last row. I'm printing that 5/1/2016. Okay, that's it. So 5/1/2016 means May 2016 from January 1964. This is the data range. Okay. Now, so this is a monthly data. So time series data, it will not automatically get considered within R. For that, we need to make time series object. We need to make time series object. So this line of code piece is creating a time series object. Okay. So how we can create time series object in R? This is a TS command. It's a TS command. My vector means the numerical data, which is a time series in order. And then we need to put up the start, end, and frequency. Okay. Start, end, and frequency. So let me explain. First, frequency I will explain. So there is a thumb rule. So in R, first two questions you need to ask yourself. First question, which kind of data is this, monthly or daily? Monthly. How many months are in a year? The answer is 12. Then frequency will be 12. Frequency will be 12. Okay. So for yearly data, for daily data, how many days are in a year? Answer is 365. Then frequency will be 365. Okay. If for yearly data, how many years within a year? So for yearly data, what will be the frequency? That's my question. I can repeat. For yearly data, what will be the frequency? This is a monthly data. How many months in a year? 12. The frequency will be 12. How many days are in a year? If it is a daily data, how many days are in a year? 365. Then frequency will be 365. Sometimes in many people it puts 360 as well. Okay. And how many? So if it's a yearly data, then what will be the frequency? Let me know. No answer? For yearly data, what will be the frequency? Am I audible? Oh, sorry.
Yes, sir.
Yeah. I can see the answers now. Yes. I can see the answers. Yeah, the frequency, yeah, Pranavendra. This frequency is creating time series object with respect to that frequency. Okay, the command, R command. Okay. So for year it will be 1. No, not funny, not 365. This will be 1. Okay. Now, though it's a monthly data, two things will suffice. So year and month, and this is year and month again, start and end. That's it. Your time series object has been created. Now try to plot this. Plot my TS. I don't know how it works. Okay. Now see, this is the plot. This is the plot. And you can see the time as well in the horizontal axis. And vertical axis, you can see the data, the women employment data, employed women data. Yes. Okay. Now after plotting, and for weekly, what will be the value for weekly? What will be the value of frequency for weekly? Okay, 52, because there are 52 weeks in a year. How many will be for quarterly data? 4 quarters. Okay. And how many for if it's a 6 monthly data, half yearly data, then how many? 2. Fantastic. Okay, don't forget this. Now this is a library. Hopefully you all have this library. I'm putting this library at the top, library deep player, and using this library deep player we are doing something. So D, I'm referring D as a new time series data, only time series variables D, and then D lag 2, D1 lag 2, D2 lead D2. Okay, now see D1 and D2 value, you will understand. And you should understand D1 and D2, then you will understand how it is getting represented in R, what I showed in the PowerPoint presentation. Very simple code piece. Let me know if you have any question. I'm waiting. Hopefully there should not be any question. Yes. Yeah. So one in the is the one in the lagging and leading. Yes. It should be 1 to 12. No. So just example, you can put 1 to 120 as well. Just an example, funny. 1 to 120 as well. Okay.
Sir,
Yeah.
sir, in terms of this time series, if I want to summarize this graph, then how will I do this?
You want to summarize this graph?
Yeah, so if suppose I need to explain it, means totally I have done up to this, I have created up to this graph. So if I want to summarize this graph, then how will I do it?
Okay, so that
Means
depends
in terms
on
of
your
time and series.
yeah, that depends on the how. So summary means so see, for me the summary is it's starting from 1964 and up to 2016. It's varying women employment data. It's a increasing trend all over. Okay, so for this summary I will let me explain you the time series components. After that you will be able to summarize a little bit.
Yes,
okay,
sir, I'm looking for that only.
okay
Okay, sir.
Okay then. Okay, so is this clear so
Yes,
far?
sir.
Okay, now now let me show you the So some autocorrelation things I will be showing you. So if the autocorrelation between two period, or autocorrelation between lag 1 and lag 2, so some inference you can draw out of this. So autocorrelation range -1 to 1. -1 to 1 autocorrelation is ranges. So if autocorrelation is very close to 1 or -1, so there is a relationship between the lags. If it's close to 0, then the chance of relationship is very less. There is no relationship at all in terms of linear. Okay, so this autocorrelation, some of the autocorrelation graph I do have. So you just have a look, and after that we will jump into the components. Okay, so autocorrelation function, this is autocorrelation function of a particular. So this is called autocorrelation ACF graph. Okay, so for this lag 1 and lag 2 and lag 3, it's so we are plotting this. So what is the autocorrelation in lag 0? Can you tell me what is the autocorrelation at lag 0?
The invariant values.
It's 1, right? Autocorrelation lag 0 means it's the same time series we are considering for correlation. Autocorrelation of lag 0 is 1 always. Okay, so this particular example you are seeing, so this is the autocorrelation graph. In this autocorrelation graph, 1, 2, 3, these are the autocorrelation values at lag 1, at lag 2, at lag 3. Now I'm moving onwards. So this is another graph, another set of time series. This is autocorrelation plot. You can see at lag 2 it's negative 0.8, and lag 3 again it's jumping nearly positive 0.8. Again it's jumping at lag 6. So some kind of oscillation you can see in the relationship, some kind of oscillation you can see. And this autocorrelation function for decision KW, so this is another pattern. You can see another pattern of autocorrelation. So these are the things, when you get some expertise, you can see and you can infer out of these autocorrelation graphs. Okay, it's too early, so eventually you will start connecting these things. So now before that we need to go into the time series components. So time series, for a time series data, there are different components we do have in real life. Okay, for time series. So let me explain that first. So two broader parts. We have segregated this: signal and noise. And in signal there are 4 parts, like label, trend, seasonality, and cyclical trend, cyclicity. Okay, so well, this is my time series. This is a time series. In this time series we have 2 things. First one is signal, another is noise. And what is signal, what is noise? Signal is something which is regular in nature and which is an indicator in nature. The property is indicating something conclusive. That's why the name is signal. And noise means noise, nothing we are getting out of that. It's complete noise, right? So that's why this naming convention has been considered. And in the signal there are 3 things. First one is label. What is label? Label, I will tell you very harsh example, very harsh, don't mind. So this is the reality. So you see in September 2019, sorry, this is September 2019, 19. This is September 2018, and this is September 2020. Now see, this is the apparel sales. Apparel means apparel, our regular wearings. Okay, apparel sales in September before puja in West Bengal. It's the festive season, right? So Dashera, puja and all, this is a festive season. In festive season, this is the usually apparel sales curve. This year that will be like this. This will be like this in festive season. So clearly this and this, they are not in same level. This one, they are not in same level. Level means all over average. All over average means, so are you spending in millions, or are you spending in billions, or are you spending in thousands, are you spending in lakhs? So that's different levels. Levels means different perceptions of a time series, different perceptions of the quantity, different grain of the quantity, different gradation of the quantity. You can see. So levels, I will give you another example of level. It's a time. This is one level. This is one level. This is level 1, and this is level 2. This is level 2. These are two different levels. Okay, where the drift, the average is hugely different. So now internet usage of internet, you can say in 2000, yeah, up to 2008, you can consider this was the trend. After 2008, you can consider this part, this boom of internet and internet usage and your digital data sources usage and all that. Okay, they are completely taking to another level. Might be in after 2030, this will be at another level, that will be L3. So this is called level of a time series. This is the first component. Okay, so now level is done. Now trend. What is trend? Trend means it's eventually long-term movement of the time series. Long-term movement. This is the level is one. It's the same level more or less. There is no significant jump. It's a consistent, but it's always significantly increasing trend. It's trend. So it's a long-term movement of the time series. It's called trend. Okay, this is the second component. So what are the components? First one is level, second one is trend, and third one will be our seasonality. Seasonality means let me show you one example. Seasonality means any repetitive nature in the time series. So you see there is a peak in every similar gap, there is a peak. Okay, any repetitive movement after fixed amount of period in time series is called seasonality. That seasonality can be weekly, that seasonality can be monthly, that seasonality can be yearly as well, like our apparel sales. This seasonality, this seasonality is getting affected this year in apparel sales. Okay. For this this COVID situation and all. So these three components. The third component I have also already explained, that is called seasonality. Seasonality is the third component. Now, give me some examples of seasonality from your side as well. I am expecting something. Some examples of seasonality. Yeah. I can give you a break of 5 to 10 minutes. Just after 5 to 10 minutes. Buying AC in summer, yes, it's an example. Okay. So let us come back. Let us come back with some examples of seasonality at 15:45. Okay. Yeah, Madhusmita, correct. Retail sales in during puja, correct.
Yes, sir.
Monsoon in India. Okay. Let us assemble again. 5:45. 15:45 sharp. Don't be late. Thank you. Everybody in? Okay. Okay, let us start. So examples of seasonality, right? Examples of seasonality. Am I audible, right? Okay. Yeah. So examples of seasonality. Examples of seasonality means you are saying that apparel sales, retail sales in particular years, and monsoon, weather in monsoon, the rainfall in monsoon. Yes, those are seasonal effects. Okay. And another example was sales of AC in summer in India and Southeast Asia. Okay, those are also examples of seasonality. And most importantly, seasonality have a shorter period of repetition, like 1 year, 6 months, 4 months. These are the period of repetition of seasonality, right? So our new discussion item will be, so three seasonality. In seasonality, we have a couple of things to discuss. One is period. Period of repetition. Period of repetition. Period of repetition. Okay. So period of repetition is typically week, 1 week to 1 year, shorter span, 1 week to 1 year. Okay. And in a particular time series, for a seasonality, the length of seasonality, the period of seasonality, period of repetition for a particular time series will be nearly same. So it's not that for a particular time series there are seasonality in 1 week, and the same for same reason the seasonality is fluctuating for a period of 6 months, 7 months, 1 year as well. So that should not be similar kind of seasonality you can consider. So for a particular time series, the seasonality, the period of seasonality would be constant, more or less constant. It's not that it cannot be 11 months and 12 months, but it cannot be 1 month and 12 months. Okay. So period of seasonality is constant for time series, a shorter time period. Okay. And another observations in seasonality, seasonality can be present with trend as well also. Seasonality plus trend. Okay, this is just another so it's not that they are different. So in a time series, seasonality and trend we can have. Okay, that's it for this. Now I'm moving into another view. So this seasonality, the trend is constant, more or less. The trend is constant. Okay, for this kind of seasonality, and for this kind of seasonality, you can see the trend is The trend is increasing. Increasing trend. Trend increasing. Trend increasing. Increasing. Here the trend is constant. Trend is constant over the period. Okay, trend is increasing. Another example I can give you. Trend is decreasing, right? Trend decreasing. Okay. Now, let me show you what. Yeah, this one. What is the pattern? Can you tell me? Is there any seasonality? There are two questions, precise questions. Is there any seasonality? Is there any trend? Is there any season? If there is any seasonality, what is the period? What is the period of fluctuation? More or less. What is the period of fluctuation? And if there is any trend, which kind of trend? It's increasing, decreasing, or something like that. Let me know in this plot. Okay, just two answers. What are the answers? Yeah, increasing trend. Seasonality is present. Yes, seasonality is present. Seasonality is present 10 years. 10 years you are saying, funny. Yes, that may be 10 years. Yes, correct. So from every midpoint to another midpoint, you can assume. Yes, every 10 years there is a seasonality, and it's an increasing trend. Perfect. Okay, good. Go ahead. Now, so this is seasonality. Now, this is another kind of generalized thing, which is periodical in nature, that is called cycles. And cycles or cyclicity is another component of time series. Which is actually having more than 1 year period. Usually the period of fluctuation is more than 1 year, and that period of fluctuation is not constant always. I will give you an example. This is the third component, right? This is another component under this is, what is the signal? Under signal, it is the third component. Cyclicity. Cycles is the name. Cycles. This is a time series. Okay, let me draw a better diagram. So this is in 1911, 1912, something like that. 2000 is 2020, 2020. Okay. Okay, you can assume that these are natural calamities. The financial loss graph due to natural calamity. You see the periods, these fluctuations are not regular in nature. These fluctuations are not regular in nature. These are not regular in nature. but there are fluctuations, right? There are fluctuations, and the period is not also same. This period, this length is not equal to this length, this period. Okay, so some examples, and there can be same as well, but the length will be greater than 1 year. So seasonality is similar to seasonality in some times, but it's more than 1 year. Well, suppose so in 2000, in 1990, after 1995, 1996, so during the World Cup season, we have a peak in the TV sales in India, television set sales. Now it's online. We can see now television is not that much the only medium to watch matches, football matches, but up to 2005-06, every 4 years there is a peak in the television sales during football World Cup. So that's a cycle, that's the cyclicity of the time series, and this analyzing this will be little bit more complex, and it will be rigorous, and it will be will need more data coverage to analyze these cycles. Okay, so cyclicity is it's little bit complex in nature. So as so far, so this is cycle, and can you give me any example of cycle? Cyclicity, so period in level both can differ different for every peak. Yes, yes. Seasonality is less than 1 year. Yeah, 1 year, 1 year you can say 1 week to 1 year. It can be daily as well in some of the cases. In daily, can you, Preeti, can you try giving me one seasonality example with the period daily? Seasonality can occur daily as well. Any time series example anyone can give me having a daily seasonality. And another ask for you, a cycle example from your side, 1 or 2 examples. Like natural calamity, due to financial loss due to natural calamity, that is one cycle. Okay, daily temperature. Okay, temperature is fine. Perfect. Perfect, Pranavendra. Server downtimes. Server downtimes in Delhi, right? Correct. Weather forecast. Yes, yes. It's another thing. In weather, there are it's a yearly thing, not daily, Tarundi. Rainfall duration, rainfall, not duration. Rainfall duration, it's very own to rainfall. How you are managing the data, how you are representing the data, that is important. If it is represented against time, then it's a time series, and within that rainfall duration, it's again seasonal thing, not daily. And rainfall duration, you are saying it's a cycle. If it's, we can think about that. If it's cyclicity, could be business. Yes, business cycle. Perfect. Business cycle. Durga Puja sale is a cycle. No, it's seasonality, Sonali. Durga Puja sale, yearly. It's seasonality. That's it. Okay. Should move away. Should move in. Finance. Yeah, financial cycle. Yes, can be. Okay. Now noise. Noise is something which is unexplained, which is not we cannot explain really. Noise. As you can see in this diagram, it's a small pictorial of noise. This is very unexplained, very irregular in nature. That is called noise. It's a error component. Okay, so noise, so signal, level, trend, seasonality, and cycles, and noise error. So for our study purpose, we will be scoping within label, trend, seasonality, and irregular error. Okay, we are not thinking about cycles. It's a more involved analysis, and it's not very usual. Okay, so these three will suffice our analysis, and which is within the scope of this class: level, trend, seasonality, and irregular error. Okay, that's it. Now secular trend, as you can see, these are the pictorials. Secular trend, say increasing trend, seasonal trend, As I already explained, seasonal trend, we have already a diagram, and this is called cyclical movement. Cyclical movement more than a year usually. Cyclical unemployment rate in South Africa. Cyclical movement. And irregular components. Irregular components are very irregular in nature. There is a big peak in between, out of nowhere, and at the tail there are small peaks. They're very irregular in nature. You can see. Okay. Now smoothing techniques. Moving average and weighted moving average. These kind of things I will explain little bit. After that, before that, let's try decomposing a time series using R. Go back to R then. And open the second code I have shared. Time series decompose. Time series decompose. Okay. Now set WD. Set WD is making error because set WD your proper provide your directory properly. Now plot. Now decompose my TS multiplicative. Now seasonal trend plot my TS. Still got this kind of plots. Then now I will explain what are the things you are getting. Just let me know when you are done generating this plot. After that I'll explain. I need answer from everyone. Yes, Preeti. So sir, out of is our data set seniority should be 1 year and cyclicity should be no. Okay, so you are saying say 10-year data. So it's depend on the cyclicity is 10 year. Yes, it's very regular in nature. That's why you can say that it's seasonality only. Okay. So there is no hard and fast. So good catch, Preeti. There is no hard and fast rule. So it's a very regular in nature, right? That's why I'm saying that is as seasonal. At least we can analyze this using seasonal techniques. Okay, Preeti. We can analyze this because it's very regular in nature. Okay, it's very regular in nature. For cycles, it's just a terminology which is used for complex thing modeling, and period is usually more than a year. But here it's a good catch. You are saying that it's a 10 years data. Still, we are saying it's a seasonality. It's a periodical fluctuation. You can say regular periodical fluctuation. We can model using seasonal techniques. That's it. Yeah, go ahead. Don't get confused. So I'm not there is no hard and fast definition, fine line. I'm just giving you an idea. No hard and fast definition that one year should be the limit of seasonality. After 1 year it should be cyclical. That's not the case. If something can be manageable, something is very regular, the periodic fluctuation is regular, that we model using seasonal techniques. So let me know if you can generate this plot, and please reply. Yes, Nivedita. Others. Orindam, Onindo, Amrita, Omio. Onindo, yes. Okay. Bindu, please do reply. Devojyoti. Yuvraj. Yeah, Sanchayata. Yeah, Pritam, metal price, yes. Metal price, it's a good example of cycles, right? Metal price. So data set seasonality should be 1 year. Okay, then now clearly you see, so in time series, what do you mean by decompose, right? You will ask me, sir, what do you mean by decomposition? Decomposition in a time series, it's a general model I am showing you. In a time series I am representing at tt. For tth time point, small tth time point, t is the value, capital T. So tt means tt means your trend. St means seasonality, season, and it means, or et, irregular components or error. Okay, so there are two kinds of models in time series we use. Two kinds of model. First one is multiplicative. First one is multiplicative, or first one is additive. 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 Second one is multiplicative. Multiplicative. Okay. In additive, the model is something like that. Yt equal to tt into st into, sorry, is for not for additive. Additive will be tt plus st plus et. And for multiplicative, it is yt equal to trend multiplied by seasonal component into error component. Trend, seasonal, and error. It's a multiplicative model, and this is additive model. So multiplicative model are usually, with time, seeing the plot, we can infer much of the things, at least these things. Seeing the plot, you see, let me show you one diagram. The same time, let me delete this. Deleting is a challenge over here. Anyways, so additive and so multiplicative and additive, how you can identify using the plot, that's the thing, right? Multiplicative and additive. It's hanging, just a minute, wait. Just wait for a minute. It's hanged. Journal hanged. Let me open the journal another time. Okay. So again, additive means yt equal to tt into st into et. Oh, sorry, plus. This is plus. And multiplicative model means yt equal to tt into st into et. Right. So now see, I am showing you one additive one. This one is additive. Okay, this one is additive. You can see the amplitude. If there is a trend, it's an increasing trend. It's an increasing trend. Trend is increasing, and there are seasonality. There are fluctuations. These are fluctuations. And what is the length of fluctuation? The length of these fluctuations. These are very same in nature, in length. The fluctuation lengths, they are similar in nature, right? So that's why it's additive. And how will be multiplicative look like? So carefully just try to understand. Multiplicative, this one, you can see again, it's a increasing trend, and the length, just look at the lengths of the seasonal fluctuations. Right, here this is t, here again this is t, this is t. Length of the seasonal fluctuations are itself increasing, jumping with the time. Okay, let me put you another example, give you another example on the board. Just a reverse. With the time, the amplitude, the length of the fluctuations are decreasing. Again, this is another multiplicative. This is also m, this is also m, and this is a. This is a, additive. Okay. So multiplicative and additive. Hopefully you are clear with this. Let me know. Understand which one I need to crop? Okay, select and delete. Okay, so that time. Won't the multiplicative model pass through 0 many times, as et may also be 0? Yeah, et can be 0. Yes, et can be 0. 0, there is no existence. That's why it will not get multiplied. It will not have there to multiply. Okay, just do a log transformation. This is not, don't think that they are actually getting multiplied. Okay, don't think that they are actually getting multiplied. This is a standard model. Multiplicative means amplitudes are varying. So Pranavendra, don't take this thing literally. These are models of hypothetical models what time series is getting followed. So the components are multiplied together, components are distributed together. Okay, Pranavendra, don't take literally. We are not multiplying anything. These are models. Okay, so it is 0, then should we consider additive model? Yes. No, that's not the case. That's not the case. Here you can see also. So okay, if you are getting confused, just remove this ET as well from this model. TT into ST, TT into ST. ET will be anyways there. Error will be always there. You see, there will be such small fluctuations within, right? For this time series, if I am zooming this part, you will see I'm zooming in this part. You see, there are small fluctuations within. These can be also errors. Okay, in this plot, you can see there are small fluctuations within. Can you see the small fluctuations within in this plot? This is the original plot. Small fluctuations, right? Let me show you this one. Yeah, small fluctuations within small fluctuations. Those can be also errors, right? Those we cannot explain. We may not, during forecasting or during approximating this data curve, we might draw a line. That line will not explain everything. Okay, Pranavendra. Hope I am not confusing your understanding. Okay, okay. Now, what do you think? This is a multiplicative or this is a additive one? What do you think? This plot, after executing this plot, this one is additive or multiplicative? This can be considered as additive, right? Because there is not much differentiation after plotting in the length of those peaks, right? Length of those peaks. Yeah, I can crop this in a paint. Can crop this in a paint. Let me on print screen. This is a paint. See, so this is I am just try to approximate this curve. So there are peaks, right? This is one amplitude, this is another amplitude, this is another amplitude, this is another fluctuation. So these fluctuations are not varying much with time, so it's not increasing, it's more or less same. That's why as a whole broader sense we can take this as additive. Okay, these are the small decisions you're just taking during composition. That's it. Okay, so make this additive. After that we will try again doing the multiplicative one. Okay, additive, plot. So see, this plot, this is the syntax in R which is actually explaining the components. The first one is the actual time series, the second one is the trend. You can see there is no small fluctuations. It's a simple straight line or something, simple curve. That is actually the trend. Okay, now this is the seasonality. You can see these are regular fluctuations within regular period, fluctuations within the same length period. This is seasonal component, and this is a random component, which is, if you can zoom in, you can see this random. So now notice the scale out of that. So for observe, the scale is varying from 15,000 to 60,000, I guess, right? And for trend, the scale will be similar. It's the trend, right? It's the main component of time series. What is the major value of chunk, right? The scale is just 20,000 to 50,000. And in seasonality, watch out the scale as well. The scale is 400 minus 400 to plus 400. So actual value is in thousands, 15,000 to 20,000, right? Or 60,000, 15,000 to 60,000. But the seasonality scale is very small. It's minus 400 to plus 400, right? So these are the small fluctuations. Those are seasonalities. If you can zoom in somehow, I don't have Photoshop. I don't know Photoshop. But if you can zoom in, you can see the seasonal fluctuations are very small and varying between minus 40 to plus 400. Okay. And this is random component, and random component again, these are varying from minus 300 to plus 300. You can just see the scale. So how much we could explain via this decomposition. So original time series is varying from 15,000 to 60,000, and the train component is more or less explaining the main data part, main quantity, and seasonality is explaining plus minus 400, and error components are taking a value a variation minus 300 to plus 300 for each and every data point. If the data point is of 8,000 or 7,000 or 15,000, the 300 is error point. So plus minus 300 is the error of fluctuation. Those we cannot those we can see via the decomposition. Okay, this is the sole way to explain the time series. We're explaining the time series. Okay, any question? Let me know. How is the random error is considered? Yeah, random error is considered. So it's a decomposition technique. So there are lots of decomposition technique. So whatever you cannot find out as decomposition, the rest part will be your random error. So additive, yeah. What are the data points considered for the error? Yeah. So you explained. We find the trend, then we subtract the seasonality. The rest part we are subtracting from y. Then actually that what is remaining is error. Okay, it's an additive model. So that's why first we are taking out the seasonality, then we are taking out the first we are taking out the trend, then we are taking out the seasonality. The rest part will be, so we have the actual time series, we are subtracting y minus the seasonal component minus the trend component. The rest part will be your error. How the error implies for the negative values? Yes, sometimes the trend is more than the actual time series, then there are errors. Trend and seasonality, trend plus seasonality, we are considering more than the actual value. So more than the actual value is suppose 15,000. As a trend, this is adjusting 15,100, and seasonality it is taking as 200. So 15,000 is getting subtracted from actually 15,100 and 200. So the 300 will be the error. And if you see in the reverse way, the error will be negative. Error component. Error component is not that we are doing some error. It's a error component of time series, which cannot be explained by this decomposition. Okay, it's not our error, our fault. So let us try out this. So just try out this one, str decompose time series. Str decompose. In str decompose, we have seasonal, trend, random, these three things. Just find out the seasonal. Find out the seasonal one. The seasonal one. Find out the seasonal one. Okay. What happened here? Sorry. Thanks, everyone. Yeah. This decompose my TS. Let's check out the open R and try this out with me as well. Open R and try this out. Let's do some coding. STR, the structure of decompose. In structure, you can see these are the things: seasonal, trend, random, seasonal, trend, and random. So I need the average of seasonality, average trend, and average random. I need that. Let me know. Just make sure. So first one is seasonal. I'm saving this for you. Seasonal component. Seasonal component. Decompose my TS dollar seasonal. Save the seasonal one. Then seasonal. This is trend component. Trend component. Trend underscore comp. Seasonal my TS. I need everyone to write, please, else the things will be go in vain. Will not remember anything. Trend component. Okay. Now trend component. Now random error. Random error component. Decompose my TS dollar random. Okay. I need these three things for mean, median, these two things for everyone, for every these three. Just do that quickly and let me know if you are done. Everyone is quite comfortable in R hopefully now, so should be doing around one most of the value. Done, sir. Okay, Madhusmita, done. Okay. What is the mean of Sonali Chakraborty? Done. Okay, fine. Let's wait for others for 1 minute.
Okay, sir.
Yeah, perfect. Answer me 1 to 1, please. Answer me 1 to 1, please. Mean, median. What is the correlation between seasonal component and trend component? Who already did the mean and median? Let me know. And what is the median, by the way? Median, you are not replying. Rupam, what is the median? Madhusmita, what is the median?
Sir, previous to that, I'm getting error because this operator is saying it is invalid. Compositions I am trying to create.
0.9992161 median of seasonal.
Median of seasonal. Okay,
Yes,
so
0.
so any challenges you are facing in my decompose my TS?
Yes,
No.
sir. No, not
Okay.
in decompose my MITS. After that, if we are trying to run those seasonal composition, trend, and random error, then the it is telling that operator is invalid. This fixing this dollar symbol.
Okay, this one operator is invalid. So you have to just clear and rerun again. I think there you face some problem in Decompose. Rerun that
Yes,
again up to this. Whatever code you already have, just change that
yeah.
to multiplicative to additive. Okay, additive.
Okay.
Sorry. I need to make. I myself also need to rerun. Now I have rerun exactly. Now decompose my TS XTR. STR in clearly in STR it is showing that dollar seasonal. Then decompose my TS dollar seasonal, decompose my TS dollar trend, decompose my TS dollar random. Now mean. So now mean I am saying, so I am putting a header as mean. Then after that I will be putting a header as median. Okay, for mean of seasonal comp, mean of seasonal computation, mean okay, mean season is minus 2.18. Perfect. Now then mean trend. So trend should be before media season. That's my, you should do that. Mean trend. Mean trend is trend component. That should be trend component. It's wrong. Okay. See, for mean in trend component, it is showing NA, right? Everybody is getting NA. Why? Because there are some NA values, not applicable values. There is one not applicable value in trend. So we need to ignore that. So NA, so for that NA dot RM equal to true. Sorry, NA dot RM equal to 3. So now mean trend will be this. Do this thing with me. 38,484 mean trend. Okay. Now, what is the syntax of median? Who knows? Reply me in private. What is the syntax of median? Correlation is NA dot RM. Rupam, do NA dot RM equal to true and try them. Median SS true. Okay. Anything else? Using percentile, using quantile, anything? Just Google and let me know. Percentile, quantile, any other function you have? Median, I am waiting for your reply. Okay, median, I will see. Nivedita, give me some time. Mean trend component, Nivedita, just do NA dot RM. That's why there is a NA value, that's why it's coming as NA. So every time when we are calculating mean, we should do this, use this, we should practice this. We should be putting NA dot RM equal to 2. Perfect? Always, every time. Because there is no guarantee. So you will be dealing with huge amount of data. NA can be there. Then it will be done. Okay, median. So median is fine. Another syntax I need. Another syntax using percentile, using quantile. See, anything else is available? Quantile. How? Pronamendo, how quantile? Let me you execute and let me know. Quantile X 50%. No. Quantile X. How you can see quantile X 50%? Just execute and copy paste in my window, private window. execute and copy paste. First execute successfully, then let me know. Yeah, quantile. Okay, quantile. Okay, quantile. So how you can fetch that 50% one? There's a whole lot of values we have, right, Pranavendra? How you can fetch the 15% one? Okay, okay, Bipin, I think it's correct. Bipin. Yes, sequence, correct, Rupam. Sequence 0, 1, put, so only put only in sequence, I think only putting 0.5 will work. So instead of sequence, that just you can put 0.5, I guess it should work then. Okay, so I'm taking Bipin's answer for now. Yeah. Anyways, there are lots of things. So in this manner, you need to find out what are the things. So let me copy Bipin's code. Control V. No, I cannot copy. Copy paste is not allowed. Same. Quantile, then seasonal comp, then it is 3. Median. So let me see. Yeah, again na.rm. You should keep this na.rm. na.rm equal to 2. Just do practicing this. Okay, fine. Now mean trend difference. Okay, who is getting different mean for seasonal? Sanchoita. Okay, I'll see. I'll see. Sanchoita has getting different mean for seasonal. Sir, my output is coming as mean 0.99 for both mean seasonal and in random in a real for. Just check your code another time, Sonali. Just check your. I think you declared same variables multiple times during calculation of the mean. Okay, just check another time. And Sanchoita mean. So Sanchoita, just check and see the screen. See the screen. I have already written. If there is any difference in your code, then you might get. Otherwise, you shouldn't. Okay, and there might be additive. So you made this additive, Sanchayita? Okay, so make that additive, please. So that's why the decomposition will be different, right, for multiplication. That's why the data is different. That's why you are getting different result. So after making additive, I think you should get the same result. No, na.rm isn't working for core. Okay. Okay, sorry. Okay, yeah, core it should be the length should be same for two data set. The length should be same. I think the length is not same for these two components, so that's why it's not working. It's fine, Rupam, leave it. Just check the length. Okay.
Yes, it is
Just
saying
check the length.
unused argument na.rm.
Yeah. So Sonali, you done? Hopefully, should be. Anyone is facing problem? Median is also correct, Nivedita, the syntax, but you should use quantile sometimes, and percentile. There is also another thing, you can also use that. I think that should work in R as well. It works in Python. Mean seasonal 3 minus 3.2899. Mean seasonal. Madhusmita, it's not matching.
Sir, it's not matching. It's matching, sir. 2899 is yours. Mine is minus 3.289987.
Okay.
Matching, sir. Matching.
Okay, perfect. Median, quantile, median, trend. So trend component, this is quantile. Again, this is quantile. Trend component. Okay, that's perfect. Now just do one thing. Just do one thing. Question mark mean. Just do one thing. Question mark mean, and see at right side. See at right side is the help section of, and see there is a function trim. I was saying about trim mean. So that's what I am going to explain now. So see, there is an argument trim. Okay, just read that, everyone. Okay, so the fraction 0.0 to 0.5 of the observation taken from each of the x before mean is computed. So what it is saying actually, so you have observations. These are the observations 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. What is the top 10% observation? Top 10% observation. This is the top. This is top 10% of observation, and this is bottom 10% observation, right?
Yes, sir.
Okay. What is the top 20 and bottom 10, 20, bottom 20% observation? This is top 20 and bottom 20. Bottom 20, right? So the trim. So when we are writing mean, then value series, comma, trim equal to 0.2. That means it will take out the top 20% and bottom 20% of the extreme observation after sorting, and it will give you the mean from the rest. And if you are saying that it is 0.1, then it will trim out or ignore the top 10% and bottom 20%, and it will give you the average from the rest. So for 10%, it will only discard the top 10 and bottom 10, 1 and 10. That's it. Understood? Yeah. So now in this manner you can apply the trim mean. So I want you to calculate the trim mean for seasonal component and trend component. Okay, random. Why we are ignoring random error? Random error also you can calculate, right? Random error mean simple mean I am calculating for random error. You just can calculate. Just copy paste properly. Cut it right thing at right place, and you can random error. Okay, this should be median. Random error median and a median. Now trim mean, quickly we should calculate the trim mean as well. This is trimmed 10%, do a 10% trim seasonal component na.rm and then trim equal to 0.1. See, this trim mean seasonality normal and trim mean and normal mean seasonality. Just check, those are different. So we are, after removing the outliers, top 10% and bottom 10%, the value is getting shifted little. It's a significant shift, right? For let's do that for trend as well. Let's do that for trend as well. In trend. For trend, let us see the difference. You are doing that right. You should do that with mean as well. So see, it is shifted little bit, not mean trend, mean trend. So 38. So actually, if you can see, trim mean trend is 39,030 and normal mean of trend is 38, shifting upwards a little bit. Okay. So these are the holistic analysis of the entire time series, you can say, in terms of your, without forecasting everything, everything you can chalk down, you can draw down the inference out of that time series in this manner without doing any kind of forecasting. Okay. Now let me tell you what is forecasting. So any idea what is forecasting? Any thought from your side? What is forecasting? Forecasting time series. What is forecasting? Prediction of future event, present and future value based on the data history, calculating the future value based on the data history. Nivedita is answering that. Okay. Present and future values on the basis of previous years. Prediction of future event on the basis of previous years. Yes, Rupam. Yes, Nivedita. Prediction of future beyond available data. Future beyond available data. Calculating the future events, predictions. Okay, perfect. So you have an understanding of forecasting. Then what is back forecasting? Predicting the history. If you don't have the history, predicting the history. And forecasting means predicting the future, what you don't have now. Something in the back, in the history might be you might miss, that is back forecasting. And something in the future you don't have, that is called forecasting. Okay, predicting that essentially. So time series forecasting Yeah. So what was the answer? Archaeological matter. Okay. Now, so forecasting time series. So forecasting time series, for to forecast a time series, what we have now on the table? What we have? First, the observed data, observed time series. Second, seasonality. Seasonal after decomposition, the seasonality. Then 3, the trend, error component, and 5, the plot, the intuition, right? Intuition. These are the things we have to forecast a time series. What are the usage of time series forecasting? Where do you really want to forecast time series? We want to be some Jyotish and all, or anything else? What are the usages? Let me know. Business profit, okay. To take decisions, okay. Perfect. Any particular time series forecasting problem, sales target to be done, any particular time series problem you have in mind? Stock market, GDP forecasting, okay. Stock market forecast, GDP forecast, yes. Lokesh, correct. Bipin, to plan production, okay sir, that's the objective. Share value determination, so that we can earn more. Yes Madhusmita, correct. Anything else? So number of coronavirus forecasting, right? Number of coronavirus case forecasting in India in July. That's a joke for us now. Okay. Anything else apart from jokes? What is the calculating NPV, net present value? Wow. Net present value, right, Pritam? Am I right? Okay.
Sir, if someone asks us to prepare a predictive model, we can
Yes.
input time series in that.
Depends. If that's the time series data, so is it a time series problem? Not always, Madhusmita. If it's a
Okay, sir.
decision, it's a classification problem, you cannot do a time series, right?
Okay.
Always.
So,
So something which is varying with time, then and you want to predict with time as well, then it's time series problem. You can use
okay, sir.
time series techniques. Okay.
Okay, sir.
So not
Yeah.
everything can be, yeah. Go ahead.
So I was asking that this COVID-19 data, like now the recent trend is that we are forecasting that which areas are affected. So if someone wants to prepare a project on COVID
Okay.
data, so which model they should prefer? They should go for predictive model or something else?
So there are lots of things which are involved. First, you need to get the data, what data you have, what information you
Okay.
have. Okay, it's a
Okay, sir.
multivariate time series thing. Multivariate.
Okay,
It's
sir.
not a univariate. So whatever we are discussing today, it's a univariate time series. We will
Okay, sir.
get some light on multivariate time series as well. So it's a
Okay.
multivariate. So lots of things. So how they are taking care of their patients, how many hospitals are there. Okay, what is the
Okay, sir.
length of lockdowns and all. What businesses are open. What are the transports? What are the rules of transports? How the CMs of that particular place, or I should say administration of that particular place is taking care of the things, how the awareness is, what is the basic education level about COVID in that thing. Lots of things are involved in between. It's a
Got it.
multivariate time series, Madhusmita.
Got it,
Okay,
sir.
it's not
Okay.
that easy. So I'm just giving you an
That's why I
example.
asked, sir.
So, yeah,
Yes,
yeah,
sir.
sure. Yeah, definitely. Hopefully I didn't make you confused. Are you clear?
No, no. Yeah, sir, I'm clear about it. Actually, I was asking that which model it should be suitable for.
Yeah,
Which,
it's very difficult to say. It's very
Yes.
difficult to say. So first we need to see the data. What are the data points you already have? Then we can
Okay.
propose the analysis. Okay. And though in terms of economy, some in terms of economy and in terms of everything, now the things are little bit stagnant, right? So there is
Yes.
not much effect of time in. So from June to July, I don't know whether there will be much improvement in terms of. So is there any time effect of time? I'm not sure for June, July, and August. After August, there will be, hopefully.
Okay, sir. Okay, sir.
Yeah. So
Okay.
the effect of time we need to be very conscious. So is time is at all effect at all time is important here. So for June, July, August, I think the things is gonna be
Sir,
same.
maybe, because from August onwards, they'll go for the deterioration phase. Like this
Yes,
at
yes,
this
yes,
time, this at time phase, it was at maximum. So, but
yes.
after August, September, if there is a deterioration in that COVID-19, then they'll go for what is the minimum rate in which area and all. So hence, I
Yeah,
guess that time is affecting.
yeah, maybe. Yeah, using the graphs of different country, we can
Yes, sir.
assume that this is the peak. Hopefully, it should
Okay.
be.
Okay.
It should be.
Okay.
Yeah. So
Okay, sir.
again, depends on the analyst who is working on this.
Sure, sir.
Okay.
Yeah.
Yeah.
I was just asking because I had a confusion, sir.
Yeah. Sure.
Okay.
Sure.
Thank you, sir.
Yeah. Now temperature. So forecasting. So what we have now? What we have on the have? So plot we have, the intuition we have, the error, the time series, the time points, the observed and seasonality trained error. These things we already have. Okay. And what we are doing using this thing, what we are doing and how we are validating the steps, right? What are the steps? Now give me 10 minutes or 5 to 7 minutes. I will explain what are the steps we will follow. And in the next class, it's a long session. So from the next class onwards, we will do some bit of forecasting. We'll start bit of forecasting before going into little bit advanced things. So now see TYT. This is a representation of time series. Okay, representation of time series. This T1, T2, T3, and this is YT1, YT2, YT3. This is the data we have. Okay. So the first step, what we will do? We will do a split. 80% of the data we will take as our training. This will be our training, and 20% of the data from the rest. So this will be in order. 80% from here, from the top, and 20% from the rest. We will take as our test, the first thing. Okay. And after that, after analyzing all the things, we will fit it a suitable model. A suitable model, right? A suitable model. So model, I am giving you a star. It's a star. It's a suitable model we are doing. So let me clear a little bit. So after doing that, this is the first step. After doing that, the 80% data, the 80% training data, that means the training data, that is the 80% of the data, training data, we are going to feed in a model. Okay, feed in a model. After doing the model, we need to understand that whether this model is good or not, right? For that, we already saved some test data, some 20% test data. So these 20% test data have some YT already, YTX, YT, YTX1, X1, and so on, right? So let me clarify this. Suppose last we have 100 data points, and last 20 data points we are using as our test data. Then, so using this model, what we are doing, we already have the test data as y81, y82, y83, right, and so on. And using model, we are predicting forecasted f81, f82, f83, right? We are doing that. And this y81 and f81, y81 is forecasted by, so what the forecast of y81 is f81. So what is the error then? What is the error in prediction? So we need to measure the performance, right? So model will, in model there must be some error. There should be an error. We cannot make a perfect model which is predicting everything with zero error. It's not possible, right? So always there will be some error. How we are measuring that error? This measure is y81 minus f81, y81 minus f81, y82 minus f82, okay, and so on. This is my error. Okay, now for you tomorrow to think and come back with the idea that what is the problem of, so how we can measure performance of a time series model. And in measuring performance of a time series model, if we take the error as y81 minus f81, the simple subtraction, then what will be the problem? And let me know your thought. Just think about that today and come back tomorrow. Okay, am I clear with my question? Yes or no?
Yes, sir.
No, tomorrow is not doubt class, time series only. Yeah, time series. So we just started time series. We'll go little bit forecasting, then little bit advanced. Okay, the question is, we need to measure the performance of a time series model. So in measuring the performance of a model, if we use this error, if we use this error, f81 minus y81, and we are doing some sort of average or something like that, what will be the problem? Simple subtraction. Okay, that's it. I think the question is pretty clear for everyone. Let me know if you have any doubt. And Sonali, you were asking something in between the class. I told that I'll take that later at the end of the class. Let me know that question if you have still. And any other question, if you have any doubt, I'll be waiting. Let me know. Okay, mean absolute percentage error, perfect. Yes, that is one measure. My question is, why we cannot use this y81 minus f81? Simply one f81, y81 minus f81. This error, the subtraction. Okay. Arun, you missed the class. Just you can go through the video. It's not a long video. Yeah. So who will be uploading this video? Nivedita, you will be uploading this video. I don't know who is recording.
I'm
Arun, I
not
think.
sure. Recording.
Okay, just
After,
so you are recording the class, right? Or Sagoto set it to record?
no, Shagota said it to record, but
Okay,
after
just
finishing,
okay, yeah. Sorry. Go ahead.
if I'll ask Shagota how to upload it, then I'll upload it by myself.
Okay. Just
Shagota.
do that because Arun missed the major portion of the class. Yeah, Rupam is also missed. So just tomorrow there will be class 2 to 4. Okay, Rupam, for everyone, just inform everyone in your, if you have any common WhatsApp group, anyone, anything, just do notice that it's 2 to 4 tomorrow as well. And sorry for this inconveniences. Okay, Arun, I'll clear that up. Give me time. I'll clear that up, Arun. Just copy paste the code you are running. Arun? And let me know if you have any question. Arun, just copy paste the error. Yeah, mean decompose my TS. No. Mean decompose my TS will not work. Decompose my TS dollar seasonal or dollar trend. You need to run in that manner. It's the mean decompose time series is not a series of values. It's a collection of series. Okay, you need to put just see this one. I don't know whether you will be getting this or not. Is it submitted? Just a second. So these are the entire code snippet at my point. See, this is the code snippet. Just copy paste this. Arun. Let me know if it runs, executes. Any other doubt from anyone? Yeah, funny. ACF. Yes, lag max 12. Any question on that? Yeah, partial is partial autocorrelation. It is for now out of scope. Funny. I will explain that later. This partial one. Partial autocorrelation, that means. Anything I'm missing? Any question I am missing? Let me know. R file as well. Okay, I will send the R file as well with tomorrow's class dump. Okay, with tomorrow's canvas. And Nivedita, I do have your email ID. I can send it to you anyways. But so can you upload that in Canvas? I can send that to you.
I asked Shavato, he said he'll do it.
Okay. Just this is the only change. This is the only change. You see, this is the only change at the end. That's it. And instead of multiplicative, there is additive. I will tell you that you should write it yourself. For everyone. This is the only change. That copy paste at the end. Okay, another part. So let me paste this another time. Sorry. Now take this block. Anyways, I'll send that to you. Just request Sagoto sir to upload this. Any question I am missing? Let me know. Anyone? Don't think so. I'll be waiting for two more minutes. Yeah, sure, Manjuri. Thank you.
Sir, which R files you will be sharing? This means totally
So
done
one,
or because already the files have been sent, right?
Yeah, files had been sent. Nivedita was asking. So in the lower section, I have changed something, right? I have added something.
Sir.
So that one, I already actually pinged that. In the common window, you can see that to everyone I have sent. The last code snippet you can copy. That's the only thing is changed here.
Okay, sir.
Last code snippet. If you are unable to, you're getting some error, that try to fix it yourself and let me know if you are unable.
Yes, sir.
Okay. So hopefully I'm not missing anything. Everyone is saying thank you, welcome. Okay. Okay. Thank you. Thank you. Have a nice time. See you tomorrow.
Thank you, sir.